What are some physical properties that can be used to describe matter? What are the three states of matter? Describe their similarities and differences. The science of chemistry is largely concerned with the understanding and classification of matter. This understanding naturally begins with careful observations. What does a particular sample of matter look like? Is it a solid, liquid, or gas? Is it hard or soft? Is it shiny or dull? These types of questions are where we will begin our study of matter and its properties. If you would like to refresh your memory about states of matter, go to the Phantom's Portrait Parlor, Phases of Matter, at www.mymisci.org/af/sln/phases/WATRSOLID, HTML, and view solids, liquids, and gases at the molecular level. Description of matter. Recall that matter is considered to be anything that has mass and occupies space. Matter can be best understood in terms of its properties. Some properties of matter can be determined without altering the identity of the matter, and it is there that we will begin. Physical properties, pictured in the figure below, are two very different objects. Each has a different chemical composition, meaning that each is made up of a different type of matter. Lesson content. Figure 1. A. This lamp from the country of Sri Lanka is made of silver. B. These large salt mounds from Bolivia were produced during a salt mining operation. Silver and ordinary table salt are two examples of chemical substances. A pure substance is matter that has a uniform and definite composition. All samples of pure substances have identical properties. A physical property is a characteristic of a substance that can be observed or measured without changing the identity of the substance. For example, silver is a shiny metal that conducts electricity very well. It can also be molded into thin sheets, a property called malleability. These are all physical properties of silver. In contrast, salt is dull and brittle, but it can also conduct electricity after being dissolved in water, which it does quite readily, in addition to color, hardness, malleability, solubility, and electrical conductivity. Some other physical properties of matter include density, melting point, and boiling point. There are many examples of physical properties that can be further investigated on the internet. Magnetism is a physical property. Are all metals magnetic? Find out at www.youtube.com/watch?v=sign IK-5-BRLN78. You can view a video of the melting points of various substances at www.youtube.com/watch?v=sign NYB2 ITNFCSI. Do you think metals like lead melt easily? Check out this alloy containing lead melting in boiling water. www.youtube.com/watch?v=sign JI9QKBQCUKG. The physical property density can be observed by floating bubbles on carbon dioxide. Watch the video at www.youtube.com/watch?v=sign H3EWRXRSNS. Extensive and intensive properties. Some properties of matter depend on the size of the sample, while some do not. An extensive property is a property that depends on the amount of matter in a sample. The mass of an object is a measure of the amount of matter that an object contains. A small sample of a certain type of matter will have a small mass, while a larger sample will have a greater mass. Another extensive property is volume. The volume of an object is a measure of the space that is occupied by that object. An intensive property is a property of matter that depends only on the type of matter in a sample, and not on the amount. For example, the electrical conductivity of a pure substance is a property that depends only on the type of substance. Silver, gold, and copper are excellent conductors of electricity, while glass and plastic are poor conductors. A larger or smaller piece of glass will not change this property. Other intensive properties include color, temperature, density, and solubility. States of matter. Water is a very common substance that we frequently encounter in all three states of matter. Figure below. When water is in the solid state, we call it ice, while water in the gaseous state is referred to as steam or water vapor. The physical state of matter is a physical property because the identity of a pure substance does not change when it is melted, frozen, or boiled. Lesson content. Figure 2. Water is the same substance in any of its three states. A. A frozen waterfall in Hungary. B. The Nile River in Egypt. C. A steam-powered train in Wales. Solid. A solid is a form of matter that has a definite shape and volume. The shape of a solid does not change if it is transferred from one container to another. The particles of a solid are packed tightly together in fixed positions, usually in an orderly arrangement, figure below. Solids are almost completely incompressible, meaning that solids cannot be squeezed into a smaller volume. When a solid is heated, it expands only slightly. Lesson content. Figure 3. The particles of a gas are very far apart compared to the particles of a liquid or a solid. Liquid. A liquid is a form of matter that has a definite volume, but an indefinite shape. As water is poured from one container into another, it adopts the shape of its new container. However, the volume of the sample does not change, because the water molecules are still relatively close to one another in the liquid state. Its ability to flow means that water is considered a fluid. Unlike a solid, the arrangement of particles in a liquid is not rigid and orderly. Liquids are also incompressible, and the volume of water expands slightly when heated. Gas. A gas is a form of matter that has neither a definite shape nor a definite volume. A gas takes up the shape and volume of its container. This is because the particles of a gas are very, very far apart from one another compared to the particles that make up solids and liquids. Gases, like liquids, are fluids. Gases are easily compressed because of the large spaces in between gas particles. The term gas is most often used to refer to a substance that is found in the gas state at room temperature, such as hydrogen and nitrogen. However, substances that are solids or liquids at room temperature can also evaporate into the gaseous state. A vapor is the gaseous state of a substance that is a solid or liquid at room temperature. Examples include water vapor or sodium vapor, figure below. Lesson content. Figure 4. Sodium vapor lamps glow with a distinctive yellow color. For a summary of the phases of matter, visit www.chem.purdue.edu/gchelp/atoms/states.html. A fun, interactive simulation about phases of matter can be downloaded at www.concord.org/activiti/states-matter. Another interactive simulation that will help you understand solids, liquids, and gases can be found at http://fet.colorado.edu/n/simulatio/states-of-matter. A variety of activity guides can be found by scrolling down. NASA provides diagrams and explanations of states of matter at http://www.grc.nasa.gov/www/k-12/airplane/state.html. NASA explains properties of gases in an informative website at http://www.grc.nasa.gov/www/k-12/airplane/gospro-p.html. As an ice cube melts, and it acquires the ability to flow, its shape changes, however its composition does not change. Melting is an example of a physical change. A physical change is a change to a sample of matter in which some properties of the material change, but the identity of the matter does not. Physical changes can further be classified as reversible or irreversible. The melted ice cube may be refrozen, so melting is a reversible physical change. Physical changes that involve a change of state are all reversible. Other changes of state include vaporization, liquid to gas, freezing, liquid to solid, and condensation, gas to liquid. Dissolving is also a reversible physical change. When salt is dissolved in water, the salt is said to have entered the aqueous state. Boiling off the water will cause the salt to reform in its solid state. An example of an irreversible physical change would be grinding a piece of wood into sawdust. Such a change is irreversible because the sawdust cannot be reconstituted into the same piece of wood that it was before. Cutting the grass or pulverizing a rock would be other irreversible physical changes. Some other examples of physical changes can be seen on the web. The melting and freezing of tert butanol can be viewed at these two links. Melting, www.dlt.ncssm.edu/core/chapter 2-phys-and_prop/melt_chem_cyanol-lg.htm. Freezing, www.youtube.com/watch?v=sign LQNRRIDPPLU. Iodine undergoes an interesting physical change called sublimation. Click www.youtube.com/watch?v=sign 4E0 SY-FN2M8 to watch. Metals expand when heated. This physical change can be seen using a ball and ring at www.youtube.com/watch?v=sign QNO 5IORHEQ. Lesson summary. A pure substance is a sample of matter with a fixed composition and identifiable physical properties that are the same for every sample of a particular substance. Extensive properties depend on the size of a sample, while intensive properties do not. Solid, liquid, and gas are the three common states of matter. Physical changes do not alter the identity of a substance.